Hi people, so we're going to go through in this video some of the commonplace questions for linear correlation, frequency tables, and just understanding the correlation coefficient in general. All of these questions show up on the multiple choice and on the short answer portion of the CST exam, and I think it's super important to understand what's going on here because it's bound to show up. The first kind of question that I'm interested in is one involving a scatter plot. And scatterplots have been a real mainstay of the exam for about the last 5 years or so. And so let's make sure we know what we're dealing with when we look at one. Now I've taken the liberty of drawing a box around the scatter plot given in a question. And it says consider the scatter plot below, which represents the correlation of variables x and y. What is the approximate value of the linear correlation coefficient representing these two variables? Now, you were probably taught in class to first draw a line of best fit, and that line is straight down the middle of the plot, and then to draw the smallest possible rectangle around that plot. And it has to be the smallest one, and it has to be perfect. One trick is to use the edge of your ruler to get a right angle on the short sides and the long sides where they connect, but make sure that your rectangle doesn't look like a trapezoid or some other shape. What are we measuring when we measure the correlation coefficient? Well, the point of this exercise is to actually find out how tightly the dots are huddled together or how much they're spread out, and that's a measure of how well correlated the x and y values are. There's a rule for that, and that rule here is r equals plus or minus, then a bracket, 1 minus short over long. And short over long are the measures of the two sides. So in my case, I've used a ruler to measure these, and I don't have one here for the screen, but it turns out that this side here has a length of 8.9 centimeters if I hold a ruler up to my computer screen. On this side, I get 2.7 centimeters. So let's determine our correlation coefficient using our formula. Now I'm going to just leave that plus minus out here, and we'll make a decision about that later. But what I can do is put the short sides and the long side in. So I've got 2.7 over 8.9. I'm going to close that up. Now do brackets first. Now 2.7 divided by 8.9 is 0.303, so I'm just going to put that in there. Oops, I'm just going to scroll back up. And that's fine. And I get an answer that's plus or minus, I'm going to do 1 minus my answer now, 0.6966. So usually we only need two values for this on our question. So I could say it's approximately 0.70. Now I'm going to leave that plus minus alone because I want us to look at the plot. Now the plot is very much like a linear equation that we've done a lot of in the other units in our course, and it's a question of asking whether the slope of this plot is negative or whether it's positive. So we can see here in the Cartesian plane that all of these dots make a linear function, and to that end our plot is actually negative. That means that the dots are huddled together at about 70% tightness on the graph. And that's really all you need to put down. If you get the wrong sign or you forget to put a sign, you lose 2 out of the 4 points on this question on the exam. So make sure you check at the end to say, is this positive or is this negative? I'm going to move down to another question that's quite common. And it's the use of a frequency table. And so I've made a question that says the following frequency table shows the number of volunteers working at a local church food kitchen according to and grouped by age. What statement best describes the linear correlation of the following distribution? So I notice that the different volunteers work a number of hours per month, and I can also see that those volunteers their ages are listed here on the left. So they range in age from 50 years old to 75 years old or older. And the number of hours that they work per month correspond with that. Now I can see a trend here that the older you are, the less hours you work. You know, do you see this here? But like the younger you are, the more likely you are to work 20 to 25 hours. So the question is how do we represent this information, or what are they asking? Is the correlation positive and strong, positive and weak, negative and strong, or negative and weak? One way to do this is to look at our table and to just sort of circle the distribution. I notice that most of my numbers are kind of clustered in here in the central part of the graph. Now, unlike on a Cartesian plane, this sort of positive slope, like what I'm doing is leaving out the zeros that are in the corner, this kind of positive sloping actually indicates a negative correlation. Now, some teachers tell their students to flip this on the page, but if my values go like this, it's going to be negative, a negative graph. And that's because the older the people are, so the greater the age, the less hours they work. So there's an opposite. It's not that the older they are, the greater the hours they work. So it's not plus and plus, it's plus and minus. I also notice that this distribution is quite tight together. There are a whole bunch of zeros in the corners here, and the numbers aren't spread all over the table. So this is actually a negative and strong correlation. Now, if those values had been clustered sort of down the other direction of the graph, like this, down the center, it would be positive and strong. But that's not the case. This is the case here. And so our answer is going to be C. If you have a graph where there's numbers all the way out, and maybe there's only a zero in the corners or just a couple of zeros, you know, these are weak distributions. It means that there's much more of a spread of data, and that our scatter plot above would have dots that are much less clustered. The final type of question that shows up, and it's often the first question on an exam, is ordering the following distributions from weakest to strongest. Well, what we know about linear correlation is that linear correlation, just as a reminder, is how tightly the dots are grouped together. So the number indicates the weak or strong, and the sign indicates the direction or pattern of the slope, you know, made by the scatter plot, right? I'll say made by the dots on the scatter plot. So if we're looking at weak or strong, we really don't need to take into consideration the signs. So I'm just going to say, well, we've got 0.72, 0.52, and 0.82. So let's ignore the sign because that's just direction. I always tell students, hey, what if these were test marks? You know, which one would be the weakest? Well, number 2 here would be the weakest. And the next best mark would be 0.72. And then the strongest would be 0.82. And sure enough, that's correct. So we would say that the order 2, right here, 0.52, is the weakest, followed by the middle, which is 0.72, followed by the strongest. So when you get a question like this, just look at the values, do not look at the signs. And, you know, perhaps one way to think about it is, what if these were test marks? What would be the weakest? What would be the strongest? And how would I order them as such? I hope these 3 questions helped you out. They're very common on the exam, and I encourage you to make sure that you know how to do them. Statistics always shows up in multiple forms on the first 10 questions of the exam, which is where you can get a lot of your points for the final.